right, pre-algebra students. So today in our lesson, we're going to extend what we already know about slope. We're going to use similar triangles to prove that the slope or the slant of a line is constant throughout. In our lesson, we will review what similar triangles are, kind of switching gears over into geometry, and then we're going to investigate slope using those similar triangles. As always, make sure that you're following along with your notes, and let's get started. So, similar triangles. Similar triangles are the same shape, but not necessarily the same size. What's cool about similar triangles is that their side lengths are proportional to each other. So in this smaller triangle, let's say we have a height of 3 units and a width of 6 units. Why not? And then in our larger triangle, since its side lengths are proportional, let's say that the height is 12 units and the base is 24 units. So when we set up a ratio of the side lengths for the smaller triangle, it would be 3/6. And the corresponding sides in the larger triangle would form the ratio 12/24. Well, we know that these ratios, they can be simplified. They both equal 1/2. So since their ratios can be simplified to the same ratio, we call these similar triangles. What's cool about these triangles is that if you rearrange them, you can put them on a line. Their endpoints would be on the same line and they would be consistent. You would see a linear pattern. They would be on the same line. So let's say we've got our same side lengths here. We could use either of these triangles to prove that the slope of this line is constant. The slope of this line in this case would be 1/2. So let's try that out. What I'd like you to do is I would like you to pause on this page and try these questions on your own. Now that we're back together, let's try this page out. So we have two people and they're trying to prove that they can use any 2 points to find the slope of the same line. So Joe is going to choose the points 0, 0, and 2, 4 to make a right triangle. So I'm going to plot those points on the graph. Here's 0, 0, and here's 2, 4. Now I'm going to draw a right triangle between those points. So here's my height, kind of a odd looking triangle there. Here's my height and here's my base. And I want to find the side lengths of this triangle. So it looks like the height of this triangle would be 4. 1, 2, 3, 4. That's my change in y, or the rise of my line. My run, or the base of my triangle, would be 1, 2 units. So using this triangle, remember that slope is just rise over run, or technically it's the height over base of this triangle, and that would be 4/2, which simplifies to 2. Now let's say that I take Kelly's triangle. Kelly is choosing the points 2, 4, and 5, 10. So right 5, up 10. And she made a different triangle with endpoints on the line. So now I need to find the rise over run, or the height over base of her triangle. So the height, change in y, would be 1, 2, 3, 4, 5, 6. 6 units. And the run, or the base of the triangle, would be 1, 2, 3 units. So for her triangle, it would be 6 over 3. Rise over run is 6 over 3, simplifies to 2 yet again. So now, how are their triangles related? So what I'm thinking is that since their ratios simplify to be the same thing, they both simplify to be 2, here's what I'm seeing. I'm seeing that the triangles are similar because the ratios of the sides are the same. The ratios of the sides simplify to the same slope. So between those points, you're going to find a slope of 2 for this line. We can use any 2 points on a line to find the slope of a line. That's the main takeaway here. The reason why is the slope of any line is constant or the same, and it doesn't matter which 2 points we use. The ratio of rise over run will always be the same. Based on what we know, which of the following triangles would also lie on the line? Let's see. Well, no matter which triangle we use, it needs to have a ratio that simplifies to 2. So let's test this out. Well, 26 over 14, that is not 2. If I look at triangle B, I see the height of 36, or a rise of 36, and a run of 18. 36 divided by 18 does equal 2. So I would say triangle B for that very reason. It's triangle B because its ratio of height over base, or rise over run, equals 2. Let's try one more example. So in this problem, it asks us to draw 2 different sized triangles that could be used to find the slope on this graph. And we're going to label the rise and run using similar triangles. So I'm just going to see, I've got a few points I could choose here. I've got 0, 0. I've got 3, 4. Let's see. And I've got 9, 12. So I'm gonna draw a smaller triangle down below. Let's use this small triangle. And then I've got a larger triangle up here. I use blue for this. So here's another triangle. And so we're going to write the ratios of the side lengths for this one as well, the rise over run, to find the slope of this line. So for the blue triangle, the larger triangle, I see that I have a height or a rise of, well, we're counting up by 2's here. So this would be from 4 to 12. That would be a rise of 8 units. And then my change in x, or my run from left to right, looks like my intervals are going up by 1. So this would be 1, 2, 3, 4, 5, 6. So those are the side lengths of the larger triangle. The smaller triangle looks like the rise, or the height, would be 4 units. And my run, or my base of the triangle, would be 3 units. So when I compare rise over run for the triangles, I've got 4 over 3 and 6 over 8. Oh, I meant to put 8 over 6. Let me change that here. And the reason why I'm changing that is because the height of my triangle, the blue triangle, is 8, and the base of the triangle is 6. So that should be 8 over 6. And if you reduce this ratio here, if you simplify it, if you divide the top and the bottom by 2, you're going to get the same ratio of 4 over 3. So these triangles are similar. The triangles are similar because they have the same ratio, and they show The line has a slope of 4/3. The line has a slope of 4/3. Rise of 4, run of 3. For additional practice with these types of problems and to solidify your understanding of how to find slope using similar triangles, I recommend trying practice problems 9, 10, and 11. So that is our lesson for today. Again, making sure that you're trying out those practice problems. Check your answers with my filled in notes and ask for support in Math Help Desk if needed. Thanks again for watching.